Have you ever wondered how a pilot knows exactly how high the aircraft is flying above the ground, even when there's thick cloud cover and no mountain in sight? The answer lies in a wonderful instrument, the altimeter. An altimeter helps measure altitude or height above sea level, not by using a ruler, but by sensing changes in atmospheric pressure. Here's the basic idea. As you move higher up in the atmosphere, the pressure of the air around you decreases. So, by knowing the current atmospheric pressure, the altimeter can calculate how high you've gone. And here's something even cooler. An altimeter is actually a modified aneroid barometer. It doesn't use mercury. Instead, it uses a sealed metal capsule that expands or contracts with pressure. And that motion is translated into a height reading. Let's break down how this works in physics terms. At sea level, atmospheric pressure is highest because the full weight of the air is pressing down. But as you go higher, say up a mountain or into the sky, the air gets thinner and pressure drops. The altimeter senses this drop and uses a calibrated scale to display altitude. The scale is designed so that a certain drop in pressure corresponds to a specific rise in height. Now here's the scientific backing. The pressure-height relationship follows an exponential decay. That means pressure falls quickly at lower altitudes and more slowly at higher altitudes. That's why the altimeter scale isn't linear. It's been mathematically adjusted to match how pressure really behaves with altitude, all thanks to physics. Let's now talk about something very important, calibration. The dial of an altimeter doesn't show pressure in pascals or millimeters of mercury. Instead, it shows height in meters or feet. To make this work, the altimeter must be calibrated to a standard pressure value, usually the pressure at sea level, which is 101325 pascals or 76 centimeters of mercury. Also, you'll notice something unusual. The height increases from right to left on the scale. That's because as pressure drops, which moves the needle leftward, the altitude increases. But if you're flying into a region with a very different local pressure, the altimeter needs to be reset to match the new sea level pressure. Otherwise, your altitude reading might be off, and in aviation, even a small error can be critical. Altimeters are more than just cockpit instruments. They're used in many aspects of life and technology. In aviation, pilots constantly rely on altimeters to stay above terrain, follow air traffic rules, and land safely. In mountaineering, hikers and climbers use portable altimeters, often built into smartwatches, to track their progress up the slope. In weather science, high-altitude balloons equipped with altimeters collect data at different layers of the atmosphere. And in skydiving, altimeters help jumpers know exactly when to deploy their parachutes, a matter of life and death. This simple concept of pressure variation turns into a vital instrument that ensures safety, navigation, and exploration, all thanks to atmospheric physics. Let's quickly revise what we've learned about altimeters. An altimeter is a specialized aneroid barometer that measures altitude by sensing changes in atmospheric pressure. As we rise higher above sea level, pressure decreases, and the altimeter converts that pressure drop into a height reading. Its scale is calibrated based on standard atmospheric pressure and must be reset to local conditions for accuracy. From cockpits to mountain trails and even weather balloons, this compact device plays a massive role in guiding human activities safely through the skies. I hope you now see how a simple pressure sensor becomes a pilot's trusted height meter. In our next concept, we'll continue exploring how physics quietly powers the tools and technologies we use every day. Until then, keep observing and keep asking why.